guys, you're doing good. Welcome to section 8.5, adding and subtracting now. Again, we're continuing our theme of treating these just like fractions. Okay, so here's your I can statement. I can add and subtract these rational expressions. Now, you might have noticed I skipped over the note slide. You can get those out of your textbook. It's just the properties if you want to see it. Otherwise, please take good notes on these examples. This will help you. Okay, so when we add fractions with like denominators, remember, you're just going to add the numerators, the top. Leave the bottom the same. We just have to make sure they are the same. So for this one, my denominators match, so I'm just going to add the numerators. 7 plus 3, definitely 10. And I keep the same denominator. I don't do anything there. You only change the denominator with multiplication or division. So I'm done. Yay. Now this one, we want to subtract. We notice our denominators match, so I don't have to worry about it. In fact, I can write my denominator in, and I'm going to subtract the top. 2x minus 5, well, 1 has an x and 1 is a number, so I'm just going to write it like that. I don't have to cancel anything. These x's are busy. They're part of an expression, so I just leave it like that. Now, sometimes, and this is a lot of words, this is a property again, go ahead and read it in your textbook. Otherwise, please pay attention to these examples. Sometimes you don't have a common denominator. Like, for example, here, they have a C and a D. So what you need to do is to find the least common multiple, or find what's in common. Okay, and here they're asking us to do that. We want to find the least common multiple of 4x squared minus 16 and 6x squared minus 24x plus 24. So what I'm going to do is I'm going to factor each one. Okay, and then I'm going to look for what's missing. So we have 4x squared minus 16. Okay, so right away we're going to pull out the common factor. 4 is a factor of both 4 and 16. So that's going to get pulled out. Okay, then I notice I have a difference of squares here. We have something being squared in the first spot, something being squared in the second spot, and my middle sign is the subtraction sign. And we're also missing that x term. So I'm going to use my pattern. We're going to go 4. My x's get split up into the first spot. What's being squared in the second spot is 2. 2 squared is 4, so that's going to go in my next spot there. And then I do a plus and a minus, and I'm done. Now, because we are finding a common multiple, it's going to help us if we rewrite this 4 using an exponent, just so we can kind of factor it out a bit. Think of your factor trees. Okay, 4 is the same as 2 times 2, or 2 squared. So it's just like doing a factor tree. You're just writing what would be squared to get that number. Okay? Now let's do the second one. We have 6x squared minus 24x plus 24. Now, right away, you might be freaking out a little bit because there's a value in front of A. Don't worry, because we have a common factor. We're going to pull out a 6. Let's see what's left. X squared, 24 divided by 6 is 4, and then plus another 4. That's actually one of our perfect square formulas. Okay, and the reason I noticed that is because something's being squared here, something's being squared here, and the middle part, x is being squared there. 2 is being squared there. And the middle part is the same as 2 times whatever's being squared in the first part times what's being squared in the second part. If it follows that pattern, it's a perfect square. And we did talk about that. Or, another way to look at it is this term, and this is actually what you guys are used to, we'll do that instead, is the middle term. Can we go 4 divided by 2 and get 2? and then square 2 to get the last term, and we can. That works out. Think of completing the square. You hated it, but you totally got how to do that. So that means it's going to fit into this pattern. Okay, I take whatever I got when I divided by 2 here, which was 2, then I look at my signs. Oh, there's a negative, so it's got to be a negative. We don't have to worry about an ending part here, which is what's good. Now let's rewrite 6. Remember, we're thinking factor trees here. We're trying to find a common multiple. 2 times 3 is 6. So I've just factored each one. Now all I do for my last step is I'm going to take each different factor, but I only want the higher degree. So if they match, I'm going to take the one with the higher degree. Okay, so here we have 2 squared, and then we have 2. I don't want 2 because it's a lower degree. I want the 2 squared. This is the only 3, so I'm going to put that in there. X plus 2, there's only one of those. But we look at our x minus 2's. Here I have x minus 2 squared. Here I just have a plain old x minus 2. I want the squared one. That is my common multiple, but since we're smart mathematicians, we're going to go ahead and multiply this out. 2 squared is 4. 4 times 3 is 12. And I have my least common multiple.